Okay, so I wanted to start off going over a few things from the lab. It looks like a lot of you guys figured, let me just flip through, it looks like a lot of you guys figured a lot of it out. But actually, Alright, so in particular, I had you guys go to this website, which when you went to that link, it would download a CSV file. So what I'm doing here is I'm creating a URL in R, and then, are you guys able to see this okay? Is that legible? All right. And then I can just create a data set called BP, and I'm going to just do read.csv, and I want to read in that location that I just created. Okay, and if we did that correctly, the data should appear here. Okay. So, so that that's a nice little feature of R. You can just read in CSV files directly. You can go through. You can download it and look at it in Excel, and then load it up if you wanted to. Okay. I wanted to address this thing about the NAs. I know some of you guys might have run into problems. So if I were to, look at the variable numeric. Let me expand this. We see that these are the blood pressures of all of these people, different from different countries. But then these last few entries all say NA, so those numbers are not available. And so when you ask for the mean of this list of numbers, it spits out NA. Okay, and the reason for that is, imagine I told you a family had 3 kids, and 2 of the kids' ages are 10, 15, and the 3rd child, I don't know how old he is, okay? And I say, well, what's the average age of the kids in this family? Your answer should be, well, I can't tell you unless you tell me the age of the 3rd child, okay? And so I could, and that's basically what R is saying. It's saying, well, we're missing some numbers, so I can't tell you the average, okay? And so what we have to say is, okay, well, just ignore the numbers you're missing and give me the average of the numbers you do have. And so that is na.rm. That's an option, and you say na.rm equals true, and it gives you the mean of the numbers you do have. All right. Are you okay with this notation of BP as the name of the data set? So, when you run this command read.csv, okay, this little arrow basically says take whatever read.csv does and store it into this thing called BP. And so when you call up BP, what it is it's basically this thing with it's this data table, okay, or R calls it a data frame, and there's a bunch of different column headings. And to address different data points, you have to you can use there's a few ways to address things, okay? So you can use the $ to get any of the column headings, and actually when you hit $, RStudio brings up the different column headings here, and so, we like to use numeric, but I could ask for, BP $year, and if I do that, it says, oh, okay, this is all everybody has the entry 2009 because this data was taken in 2009. All right. And so you're asking, why do we even have this column here? It's in case we were comparing if we compiled several different files into one, or maybe we were just in one country over many different years. Then this would be a column of interest. But here, when everything is taken from 2009, it's not that interesting. Okay, but we can ask for BP $ numeric, and then that's the list of all of those numbers. Okay. You can also address data points using bracket notation. Okay, and it's in the form row, comma, column. Okay, you put in a number for row and you put in the number for column, but you wouldn't actually type in row. You would type in 1, 1 would be the first row, first column, and so when you look at that, it's the entry in there is mean systolic blood pressure, age, standardized estimates, and then it gives you this thing that says levels. And that's because this is a label, and R doesn't know any better. It just sees text and it assumes it's some kind of factor or something. And so in case there were different entries, it would list off all the different entries that were here, okay? So there's actually only one entry for BP for that first column. If I go to let's see, the fourth column, WHO region, I could do that. I could leave the row, or I could just say the first row, but let's look at the fourth column, and it will say Eastern Mediterranean. And then it also says there's 6 levels, and those 6 levels include Africa, other things, and the last one is Western Pacific. Excuse me. All right, so you can address things like that, and if I get rid of the number before the column, basically here it just says, give me everything in the fourth column and all the rows. So when I hit that, we have a whole bunch of entries, and it gives you all 386 rows, and this is all from this one entry that says BP blank, comma 4. Okay, so this would be equivalent. What I just wrote there is equivalent as typing in WHO $WHO region. So you can address the same strip of data in 2 forms. One with the bracket notation, and the other with names. Okay, and so names are very useful for us humans. But then if you were doing some kind of programming and you want to iterate through the columns, you can do that as well using numbers. Okay, so anyway, I asked you to create a histogram of maybe the blood pressures, and then so you get something like that. You can add options by change the title. Main is basically the title, and you can just say histogram of blood pressures or something like that. And it looks like that. And you could, instead of BP $numeric, you could change that, and that would be, there's different options here. There's XLab for X label, and you could just say blood pressure. I think this is systolic, right? Okay. And then whatever you put in there, it shows up there. Okay.
How did you get to the key?
Oh, the last thing you type in, you can call that up just by hitting the up arrow on your keyboard. Okay. Up arrow will pull up the last thing. Also, you can go over in our studio up to, in the right corner, you can go to history. And it shows you the last commands you did. And let's say you wanted to repeat this command, you can just tap that and it shows up here and you can modify it as necessary. Okay. Environment shows you the current things stored in memory. And all of these other things, your plots will show up here. And if you ask for help, it will also appear down here. So these things, well, they're good. Okay, and so we wanted to make subsets. Okay, and so there's a few commands. So one is the command subset. Okay, and I'm going to ask for help on subset by typing in a question mark before the word subset. Okay, and then it says, well, what do you want to do? And when you look at the help, it feels like it's a bunch of gibberish. Okay, it's very hard to understand in the beginning. So what I like to do is I always like to go down to the examples, because the examples sound like, oh, now I can kind of understand what's going on here. Okay. So what I would want to do here is maybe I will do, I can do subset BP based on what? I want to do WHO.region, and I forgot. Let me ask for the names that exist in BP. So WHO region, it's case sensitive, so I wasn't sure if region was capitalized or lowercase, so I can say, give me the subset of BP where WHO.region equals Europe, okay? And you have to do equals because that a single equal sign is used as an assignment, and double equal sign is test for equality. Okay, there's a difference there. Okay, so one, if you say A equals 3, it's going to tell the computer store the number 3 in the variable A. Okay, if you say A equals 3, then it's asking the computer, is the variable A equal to the number 3? Okay, so you have to say equals there, and something happened here. Well, I think it's because I just said output everything. So let me just, so I'm going to create something called Europe, a variable called Europe. Yeah. And I'm going to store the output of subset into there. I was going to just show what the output is, but it looked a little crazy here. Okay, and so it doesn't look like anything happened, but if you look in the upper right-hand corner, it says, oh, Europe, 106 observations of 12 variables. Okay, so we can see that something did happen. And if I click this, then we can see, okay, the data table did appear. There's 106 entries. And we can see that for WHO region, all of them now say Europe. Okay? So that's one way to create the subset. Okay, so you can use the command subset, and you just store the output. So you're saying subset, what are you subsetting? BP. And the criteria is WHO region, you want equal to be Europe. And whatever that outputs, store into this thing that we're going to call Europe now. And so I could ask, what's the mean of Europe $numeric, which is what we use for that. And it says, oh, we don't have that. Okay, so we say, all right, well, get rid of the NAs. And it can spit out the mean there. And you can also ask for the histogram of this. Okay, and it looks like this. So that's one way to subset the data. Another way, okay, is we can create, a vector. I could just say, who.region equals Europe, okay? And what this says is, I've got to say BP, $. So it says, what I'm saying is, okay, we'll take that list, BP WHO.region, and I want to ask, is it equal to Europe, okay? And what it spits out is this list of 386 entries, and it says true, false, true, true, false, false, whatever, okay? So if the region was equal to Europe, it will say true. If it wasn't, it's going to say false. So I can take this and use this as a way to select the rows. Okay, so I could say BP, and I'm going to store this output into, I'm going to just call Europe 2, which will end up being identical. All right, so I could say go to BP, and I'm going to use this bracket notation, okay, where the things that come before the comma select the rows, and the thing that comes after the comma selects the columns. So I'm going to leave after the comma blank to say select all the columns, but which rows do I want to select? I want to select the rows where BP $WHO region is equal to Europe. Okay? So basically what I'm saying is take this thing, BP WHO region equal to Europe, which is this list of trues and falses, and I'm going to use that as a way to select which rows I want. Okay, and so when I do that, it's going to create Europe 2. Okay, and we see Europe 2 also 106 observations of 12 variables. Okay, so it's also just an equally valid way to subset your data as well. Is this okay? Making sense? Okay. All right, and so I know, it might be, I imagine some of you guys got frustrated as you were working through your lab. And there is, I think there's something meritorious about that, okay? Because a lot of computer programming and a lot of this type of stuff is like problem solving, and there's kind of like this puzzle component to it, all right? And so puzzles, just walk on over, all right? Puzzles will not be that great if somebody just gives you the answer, right? If you're playing, I don't know, if you play video games or something like Zelda, and you just have a walkthrough that says do this and do this and do this, I don't know, it defeats part of the purpose, okay? And so there's, it's good to be frustrated, and it's good to wonder to some degree. At the same time, I don't want it to just be this overwhelming burden. So it's difficult to write worthwhile labs that straddle that balance of burden versus education. So anyway, okay. So this is what we have. Did you guys? Are there any questions from the lab? Any other part of it? Yes.
So for the challenge section,
Yeah.
where you asked us to calculate the mean for each region, I got the same mean for 3 regions, which was the same mean that you got was 500.
I have a feeling something went wrong, but let's try it. Okay. So I did. Okay, so we'll do this for. I'm just gonna do it this way. So I'm just gonna ask for the mean of this thing, where I'm going to take numeric. Okay. So this is like. Remember this BP bracket BP WHO region Europe comma bracket, that is equal to having that data set of 106 entries, okay? So I'm just encompassing that into mean, and I'm saying within that look at the numeric field, okay? So this is just course, not available, so I'm going to say na.rm equals true. Okay, so I get 129.5441 for Europe. I forget what my entries are for WHO region. So let me just ask for the first entry out, the levels. So I have Africa, Americas, Eastern Mediterranean, Europe, Southeast Asia, Western Pacific. Okay, so Europe was that. We'll go to Africa and ask, what is that? Okay, so I'm getting a different answer for Africa.
Yeah, I see where I went wrong.
Oh, okay. Okay. All right, so yeah, we're getting Eastern Mediterranean. Okay. So we are getting different entries, okay? So this was, you can just change this. Do that. Okay, yes.
For that question, I used a different function.
Okay.
That was faster.
Oh yeah, yeah. Oh, what did you do? I'm curious.
T-apply.
T-apply. Oh my gosh, that's like that's even better. Okay. Have you used R before?
No, I just figured that out for myself.
That's bravo, bravo. Okay, yes. I'm trying to think how I would have to use T-apply. Now you're putting me on the spot, but no, I think let me ask for the help on T-apply. But yes, T-apply applies a function, and you would apply the function mean to it. It's, I think, let me just see if I can do this. But I might have to call on you for help here, because I think I'm going to do BP, and I want to do BP $sign numeric by BP $sign WHO region with the function mean.
And then NA.rm.
Oh, mean with the option na.rm equals true. There we go. Look at that. Okay. But yes, so yeah, so T-apply, you know, there's always, so R is this very impressive piece of software, okay? But the catch is it's got a very steep learning curve, and you're going to be hunting around. How quickly did you find T-apply, or what did you search for that brought you to T-apply?
Oh my gosh. I don't know, last night I took like an hour maybe to figure some of this stuff out.
Okay.
Honestly, I think I Googled like how to find mean of columns or something.
Okay.
R,
Yeah.
And then it gave me like a PDF of certain functions being used, and I found reply.
Right. So your best resource for learning R is the internet, okay? So you're going to be Googling R, how to do this in R. That's literally what I do for a lot of stuff. I just say, how do I do this in R? And I just write how to something something. You know, maybe that's not the best way to search, but a lot of times it's very good, and you can find applications. Okay, there's T-apply, and then there's all sorts of cousins of apply, S-apply, L-apply for different things, and you can do things like that. So, so yes, thank you for T-apply. But okay, but again, you know, you'll probably want to consult the help and search Google for, you know, how to do things in R. So, and there's always the question of, well, why don't we just use Excel, right? Excel seems so much easier. I can use a mouse and I can click things. And there's a time when Excel is useful and a time when R is useful. And I admit, for maybe a short assignment like this, Excel is probably easier and can get the job done faster. Okay, but imagine someone said, "Well, I want you to find the average blood pressure for each of these regions, you know, over you know, a 40-year span or something." Okay, and maybe you could do something with a pivot table in Excel, because pivot tables are actually very nice in Excel. But there's a bunch of different things that you'd have to do in Excel, and like if you're trying to clean up data in Excel, it can become rather tedious. If you have to do repetitive things in Excel, it can be tedious. You can build macros and, you know, write VBA code to try to speed things up, but then you're dealing with a language already there. So with R, because everything is text-based, okay, I can take basically these commands and I can send them off to someone else and say, hey, just enter these commands into your computer and it should run fine, okay? And you can also repeat things very rapidly just by building loops and just putting in placeholders for different things as well. Okay, so yeah, in the beginning when you're just trying to do something very simple, it's going to feel like, oh my gosh, I hate R, Excel is so much easier, et cetera, et cetera, et cetera, or, you know, this other program is way easier, you know, it's much more intuitive. And that's probably true, okay? A lot of things are a lot more intuitive than R. But then, at some degree, at some point, there becomes a shift where you become a little bit more comfortable with R, and the scale of what you want to do is grand enough that you can really harness maybe the power that exists with R. So anyway, that's my my plug for R, and it's free. You know, you don't have to pay any licenses or anything like that, and so you can do a decent amount with it. Okay. Other questions? Yes.
Earlier, when you found the meaning for numeric column, I just did a summary of that.
Oh yeah, summary is also very useful. Summary will give you quartiles. So you could do summary BP $ numeric, and it finds the mean, the median, the max, and the min, and it automatically filters out your NAs for you when you do summary for that.
I thought I got it, but it's the same.
Okay. So yeah, there's all sorts of functions in R, and there's no like single listing of them. Okay, you might be like, well, how do I do this or how do I do that? There's just like so many functions in R that I don't think there's a single comprehensive listing. And R is also people will write add-on packages. So what you have on your computer is going to be the base package, or the base. And then maybe somebody says, well, I found that, you know, when I want to analyze geographic data taken from satellites or something, I find myself repeating this one function over and over and over again, so I wrote a specific set of packages and functions that will handle this, okay? And you can just say, okay, well, I want to load that, what they call libraries, and you load that into it, and that extends, you know, your functionality of R. And there's thousands of packages being published every year, and it's growing. Okay, so and it's very popular. I don't know, in the academic world, and increasing popularity in the industry as well. Other questions from the lab? Okay, you'll get a break from the lab this week. Next week I'm going to assign another lab, but it won't be due until the week after the midterm. So you'll probably end up spending the week after the midterm working on it, and I'll go over a little bit of it next week. So, okay. Well, with that, we'll start this week's lecture. This thing keeps static.